Gothic cathedrals are maybe one of the best examples of the constructive achievement being equal to the structural or functional achievement, in that they are a great example of an organized, partly skilled, partly unskilled labor force that puts its knowledge to use in the service of not only actually getting the job done, of building the actual structures, but of refining the basic principles into something that's a really coherent, really integrated architectural experience. And it's the stonecutters really who have in their hands not only the structural performance of the building, but also the way that it impacts us, the way that it affects us. The Gothic job site must have been one of the most impressive sites in human history. Maybe not the scale of the pyramids, but in terms of the organization to get these things built in the amount of time that they were, even though to us they seem like incredibly long periods, they were done usually in bursts of a few years at a time, right? A town would have the funds, would be able to recruit the builders and the labor force to have a campaign to build a portion of the cathedral, maybe the choir or the transept. They were often built in phases that saw an incredible amount of energy devoted to them over relatively short periods of time. And they were incredibly sophisticated. We have evidence that some of the machinery that we saw in Roman construction, you see on the left a hamster wheel being used to raise a large block of stone, that these were used. We have evidence of winches, of cranes, of building machines that hadn't been seen in Europe for several hundred years being put to use to build these. But maybe more important was the transmission of knowledge and the organization of the labor force. The guild system ensured that the stone cutters were well trained, that they came up in the profession and not only knew how to carve the stone, but knew what the traditions were, knew what the local preferences were. And the ordering of the job site, the hierarchy of having a master builder, master stone cutters, a sort of brigade system of workers, ensured a consistency through the job site that meant that the cathedrals as they're left to us today almost feel like they're industrially produced, right? There's variation, but the variation is subsumed within the overall order. And we can look at the buildings themselves and see the way that stones were cut to various standards to understand that there was a clear hierarchy, that there was a systematic approach to carving, to moving the stones, to putting them into place. But we also have a couple of other pieces of evidence, in particular the sketchbooks of Viollet-le-Duc, who was apparently trained in building arts, but was also just something of a fanboy and seems to have gone around to construction sites sketching what he saw builders doing. Some of these are plans, but he also drew, as we saw in an earlier lecture, pictures of the machinery that he saw being put to use on the job sites. We have contemporary accounts, stained glass, as you see the drawing on the bottom that shows some of the tools that we've seen throughout ancient history being brought back into use. Carpenter's squares on the bottom, dividers that could be used to create the shapes of the pointed arches. And in some cases, we have the testimony of the buildings themselves. On the right, this is in one of the upper stories of a cathedral where the template for a particular stone pinnacle survives, was drawn out on the floor and was clearly used as a template for stone cutters to make similar pieces again and again and again, multiple times. That the stones would be cut and used in the series of pinnacles on the outside of the cathedral. So we have evidence for a labor force that was well trained. Sometimes this labor force was mobile. They would go from job site to job site whenever a town had the money. The master builder would show up and begin work, and might move on to another town when the funds ran out. But we also see the development of the Gothic type benefiting from this repeated iteration of the same type over and over again, with a skilled workforce that passes down its knowledge, right, from generation to generation. And this, I think, explains this phenomenon of what's known as the early Gothic and the high Gothic. And you remember we talked about the early Gothic being sort of working out the solution to the problem, right, finding a way to create awe-inspiring spaces large enough to hold a decent-sized congregation, but also lightweight enough to allow for plenty of daylight and eventually plenty of stained glass windows. And these basic components of the solution don't necessarily create a coherent architectural experience, right? It's only with the repeated construction of cathedrals and the kind of understanding of some underlying principles, or the teasing out of similarities, of bits of order, bits of proportion, finding ways to do things that look right, and then building on those that lead us to what we call the high Gothic, right? The total integration of the liturgy, of the structure of the building, and of the experience, the architectural experience of being within it. Now, some of this is just the scale of the building, and famously there's this progression you can draw of Gothic cathedrals getting taller and taller as builders get more and more confident in their abilities with stone. Also, as the type proves itself at different scales, right? It's one thing to build a building that's twice as tall as the previous one. It's another to build a building that's maybe 5 or 10% taller. And you can see all of these as sort of cautious steps toward the height that these buildings would end up at. But there's also a change in the style, a change in the way that the buildings feel when you're in them. And to explain this, we'll look at a couple of early Gothic buildings, most notably Notre Dame, certainly the most famous and recently the most tragic of these. And we'll compare them with high Gothic to show how the stonecutter's art really transformed or refined the Gothic solution into something of a coherent piece of architecture. Now, Notre Dame has been built and rebuilt over and over again, and a lot of what we see, particularly the spire that collapsed in the fire a couple of years ago, and the flying buttresses, are actually 19th century reconstructions by Viollet-le-Duc, this theorist that we'll talk about in a couple of weeks. But the interior shows, in large part, the original fabric, at least in the lower couple of stories. And you can see in the photo on the left that it has this trope of the piping from the vaults coming down and sitting on the sort of Romanesque pier, right? A giant column that collects all of the ribs, all of the arches, and puts it on one single piece. The other thing you can see is the type of vaulting that Notre Dame has. It has what's called sexpartite vaulting. In other words, each square module is divided into 6 separate vaulted pieces. So 2 wide ones that go along the longitudinal axis, and then 4 smaller ones that divide the side panels into 2. And you can see that creates a regular rhythm in the piping that comes down the walls, but a slightly visually confusing rhythm in the roof itself. Notre Dame also has 2 aisles, as you see in the section on the right, which means that it needs 2 stories to get the roofs over those aisles. So down at the base, the windows are actually quite far from the nave, right? They're 2 aisle widths away from the nave. And interestingly, Notre Dame was redone in the 13th and 14th centuries, and they actually changed the wall paneling. And you can see in the center photo the last bay of the nave. That's the original division. That's the original elevation into 4 segments: an arcade, the gallery, the triforium, and what was called the clerestory. In the bays in front, you can see what's more of a high Gothic division into 3 bays. So the arcade, the triforium, and just the clerestory. This is a crucial aesthetic refinement that we'll talk about here in a second. All of this is toward the idea that there's a Gothic solution, which Notre Dame shows, and there's a Gothic style, which evolves from that. And this involves the master builders and stonemasons looking at the solutions and finding ways to integrate them visually and architecturally. The high Gothic monuments generally are considered to be 3 or 4 cathedrals in particular, Reims, Chartres, Bourges, and Amiens. And these were done after there had been a few iterations of early Gothic where builders are beginning to look at it and to seek refinements. And one of those refinements has to do with the idea that, going back to Augustine, that the mathematics behind the planning, the layout, the proportions of a building are a key part of how it reflects the divine, right? In other words, if we are building an imperfect version of the heavens on earth, as the cathedral is supposed to be, then at least we can get closer and closer the more mathematically derived our building plans and sections are. And so this idea that there are perfect proportions out there that we ought to strive toward, not just in terms of the massing of the building, but in terms of our visual sense of the building, becomes important. Even though it's not something that we can find stated very often, it's clear from the development of the buildings that there's an urge towards better or more idealized proportions in the high Gothic. And one of the major steps toward this is the change from those 6-part vaults to simpler 4-part vaults. Notre Dame on top, you can count the vaults in each module, and there are 6 of them. In the high Gothic, they tend to go toward quadripartite vaulting. And if you look at the bottom photo, you can see that each vault now is basically a half square, and it has 4 vaults instead of 6. And Robert Mark suggests that this is due in part to a structural reason. If you look at the comparison in the drawing on the upper left, the sexpartite vault has a greater longitudinal thrust, and the quadripartite vault has a lesser one because of the shallower plan angle. Now, where this gets to be important is at the ends of the cathedral, both at the apse and at the nave, or at the narthex. The narthex needs giant towers, right, to stabilize the last bay of vaulting. And Mark suggests that the longitudinal thrust is actually less with quadripartite vaulting because of that shallower angle. So the towers on one end and the apse on the other end need to do less work to bookend the thrusts of the vaults. I think, though, too, that there's a visual component to this, that the sexpartite vaulting makes a disconnection between the way the roof feels or looks and the way the interior elevations feel or look. And quadripartite vaulting means that there's one module for the walls that matches the module of the ceilings, that things are integrated formally and visually. And here you see 3 of these interiors, Chartres, Amiens, and Rennes, where you get a sense that the proportions of the walls and the proportions of the roof are both in line, right? That they're both kind of singing the same song in a way. You can see, too, the development of those interior elevations, that they are both more integrated and more open, more light than in the original of Notre Dame or some of the earlier Gothic churches that we were looking at. And Jansen, in his book High Gothic, talks about the fact that this comes from both that simplification, right, going from 4 bays to 3, making each of the 3 bays taller, more attenuated, but also being braver with the kind of openness of the remaining walls. And Jansen says basically that the early Gothic, these walls all look like they are solid walls that are pierced with windows. But beginning with Chartres, we start to see the builders thinking of them as open spaces filled with delicate stone tracery, right? Instead of solid walls, we see stone skeletons holding the glass in place. And he points out that Chartres' interior makes the brave step of taking that round window that's in the triforium of the early Gothic and basically moving it up, right? Placing it between two lancet windows to minimize the amount of solid material in that wall. This is Notre Dame on the left, Chartres on the right. And you can see not only are the proportions of each bay more vertical, right, or each level more vertical, so they reinforce the kind of verticality, reinforce the height of the space, but there's also less solid wall, right, more openness, more glass in the bays of Chartres. And this really culminates in Amiens, which is the tallest of the major Gothic cathedrals, and also the one with the tallest arcades, the slenderest proportions of those side elevations, and the most glass proportionately in the openings. You can see the quadripartite vaulting. You can see that the ribs all get refined into piping that comes all the way down to the ground. So no longer do these structural elements seem to sit on heavy piers as they are in Notre Dame, but now they visually come all the way down to eye level, which integrates or ties together the interior quite well. Here you get a sense both for the piping and the kind of relentless nature of it, right? Every rib is detailed onto a piece of piping that comes all the way down the piers to the ground. You can also see, though, the amount of glass, the amount of light that's coming in from the top and really illuminating the space, right? Divine light, light from above, illuminating both our space and, if you buy into the Augustinian theology, also illuminating our souls. You can see also in the shot on the left the cracks that Jacques Heyman talks about as forming essentially hinges in the vaults that allow the structure to be a bit ductile. And here on the exterior, you can see Amiens' flying buttresses, right, that enable it to reach the height that it does. Here on the interior, you can see that everything is integrated. The proportions of the lancet windows match. So there's a continuity between the proportions of the arcade arch and the proportions of the arch of the lancet windows or arched windows in the story above. So visually, Amiens is entirely integrated, right? It feels like one idea is generating all of the details, all of the forms in a way that Notre Dame, for all of its fame, really doesn't, right? And that is down to stonemasons understanding not only how the structure works, not only how to build it, but beginning to develop the visual refinements that make it into a really coherent experience. This evolution occurs with the structure as well, and if Amiens is probably the finest visual example of the high Gothic, Bourges, at least according to Robert Mark, is the structural ideal. And he says that this one is proportionately the best. It has the kind of widest stance, the widest section of the high Gothic. It's a little unusual in that it marries high Gothic aesthetics to a double-aisled plan, right? So you have that problem of the nave being far from the ground floor windows. But to Mark, who's largely a structural engineer, the section has got it right, that the buttresses are at such an incline that they are working at maximum efficiency, as opposed to some of the taller or steeper buttresses that you see in some of the other churches. The fact that Amiens and Chartres are maybe more famous than Bourges perhaps tells you all you need to know about the relationship of pure structure to visual experience. Well, over time, tastes change, and a structural language that initially develops as a kind of pure response to functional needs becomes kind of a motif, or becomes the generator more of effect than of maybe performance. And we see what's called the Rayonnant Gothic emerge in this royal chapel in Paris. Relatively small structure, but one that, as you can see, the emphasis isn't so much on revealing the structure or refining the structure. It's on completely hiding the structure, making the structure kind of disappear in our experience. It's easy to do in a building the size of Sainte-Chapelle because a building the size doesn't really require flying buttresses. Right? It's a relatively small space. But you can see that the builders here have put the fin walls that support the thrusts of the pointed vaults completely outside of the space. And they've decorated the piers in a way that makes them almost kind of dissolve or disappear. The amount of glass in the building proportionally is much more than anything that we saw in the high Gothic buildings. And there's a sense here that the builders are going more for effect, right? Trying to really emphasize the sublime nature of the space, a mystery as to what actually holds it up. And we start to see too a more decorative approach to the vaults, right? That instead of letting the stone sort of speak for itself, there's a covering here, or colors and paints that make it much more of an interior visual experience than a structural one. And this happens too in Britain. England follows about 50 or 100 years behind France as ideas sort of migrate across the channel. But we get builders who play around with the language of the structure too. And so here, King's College, which uses what are called fan vaults instead of pointed vaults, these kind of inverse conical vaults that structurally work, but are much more difficult to build and are much more an expression of the kind of prowess or wealth of the college, that they can afford such sophisticated stonemasons to build vaults like this. Here you can see details of the fan vaults, which work essentially as they collect the loads in the same way that the pointed vaults do in the high Gothic. Here, just a rounded shape instead of a pointed shape, and you can see the rubble fill that works very much as the taille charge does in the classic Gothic buildings. So, in the last segment of this lecture, I want to look at what happens when the Gothic principles get pushed to extremes, reasons that maybe the Gothic fell out of favor, or at the very least, how at a certain point the medieval science, if not the craftsmanship, began to fall short of the ambitions of their builders. And we'll look at one famous building failure and another success that nevertheless points out what's left to do basically in the development of a true building science.